Alright guys, welcome back. Okay, so in this video we're going to design and implement our ANN model to identify figures. Okay, so we're going to be using the MNIST dataset. Okay, so if you have not watched the previous video where I explained ANN, and how ANN, like artificial neural network, relates to human neurons, I advise you to go and watch, because that will give you the background of what we are trying to code here, because it is very good for you guys to know the theory of what you are implementing before you actually implement it. Okay, so the data set that we are using is called the MNIST data set. Now the data set like comprises of series of numbers, like people writing numbers. Then we want to train an AI to learn from that data to be able to recognize figures, right? So that's what we're trying to do. Okay, so let's just start writing our code. As we know, I just copy and paste my code because of time. So the first thing that we usually do is to import our libraries. Okay, the libraries again are the things that, like the code that have been written for us to use. Okay, so we're going to be using a lot of TensorFlows, but you guys don't need to really understand how that works, right? Then I think we can, let's just run this. I think we don't need GPU for this, we should be good. Okay, so after that is done, we're going to load our data set. Okay, okay, so that is done. So now let's load our data set. So you can see that, so our data set, it's we don't have to download it, because this MNIST data set is actually available, and that's what we have in here. So all we need to do is just to load it, from here. So we don't need to do anything, which is really good. Okay, so we just load our data set in here. So we're downloading it, which is that is done. So then let's do this. So then we do something, we'll normalize our data. Okay, so what this is doing is because how do I explain this? So each pixel in this image, has some values, right? So like the pixel is this. Say this is a pixel, this is a pixel, this is a pixel. Has value that ranges from 0 to 255. 0 means black, 255 means white. Okay, maybe I will do another video to explain this in better, better, right? So now, so like this might be like 220, this might be like 10, this is definitely 0, right? No, wait, not like this is 255, this is 0, because black is 0. Okay, so like all these have these numbers, but they are big numbers. Okay, so but if we divide all of them by 255, it will bring the numbers down, and it will make our model train faster, because now we have smaller numbers. Okay, so just take that for now. I know the explanation is complex, but we normalize data so that our training process can be fast. Okay, so just take that for that. Okay, so now the next thing that we need to do is to create and compile our model. Okay, so you don't need to write all of this. Okay, so this one is just telling you that if the size of your image is not the size of your model, so see, this is the size of our model, which is 28 by 28. If you have any image, right, that is maybe like the size of the image is not the size of your model, you will have to resize the image. Okay, so the size of this image, this one, all of them, it's actually 28 by 28. That's why we have the shape of our model to be 28 by 28. Okay, so if you have any image that is not 28 by 28 and you want to use that image, you have to write this code, then you resize it to 28 28, right, based on the the size of your model, right? But let's just go with this. Okay, so this is just me explaining better if people want to use this for another thing. Okay, so now we've actually created our model right in here. So we see this is our ANN model. Like, it's a sequential model. Now we have this dent, now we have this relu, and then the activation function is soft math. You don't need to know the details of that. Okay, yeah, I'll just abstract it for you guys. But this one, so we can actually see the structure of our ANN, right? Just like I showed you guys. Now if you remember in our video, in our previous video, let me show you. You see something like this. Okay, this is the structure of it. So you can see the number of inputs neuron, you see, is 28 by 28 right here. Then this one too is 28. Then the output is 784, which is the input to this one. Then the output layer, which is the final output layer, is 10. So this one is 10 because the figure that we have is from 0 to 9, right? So which is 10. Okay, so that means the output, we give us whether our output is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 or something, right? So that's why we have the output 10, right? Because what we want to predict is 0 to 9. Hopefully that makes sense. So then this structure, it's almost the same as this, right? But we just showed it in a different way, right? Hopefully that makes sense. Okay, so the next thing that we're going to do is to train our model. Okay, so we should be familiar with some of these things in here. Okay, so our ANN model is the one that we of course define in here. Then we have our training data. To this epochs is equal to 5 is saying how many times we want to train our model, right? Now, because we said before that ANN model, we have to train it multiple times. It's just like you teaching a kid same thing again and again for the kid to know that thing better, right? So we are saying that we want it to learn 5 times. Okay, so you can increase it to 6 or 7 or 8, right? Then your model will take time to learn, but it will learn better, right? So but for now I'm gonna put mine to 5. So I expect you to just try 5 first, then you run it. So you see, based on this the speed of your system, it might take some time. So you see epoch 1, so it's going through the first iteration. After fourth iteration, you see the accuracy is 0.92, which is like 92%. You see the second epoch is going, it's gonna go like 96, 96%, 97%. Again, this might be a bit slow for you depending on the speed of your system. You see, this is almost going to like 98. Then probably it's gonna be up to like 99 point, I don't know, it's still 98. Okay, good, so we are done. Okay, so just for experiment purpose, we can increase this to 7. 10 should be 10 should be too much, maybe 7 or 8. Then you see that it will continue doing it and you probably have better accuracy. Okay, so after that we want to evaluate our model on the test data, because we have the trained data set. So let's evaluate it on the test data set. So and I'm gonna print out the result. Let's see, it should be 98%, 97% accuracy. That is good. Okay, so if you see, if you increase this to like 7, then you train it more, then this will increase, right? So when you increase this, you have to run this, right? Then you run this, then you run this. Okay, but now we have this accuracy, which is good enough. Okay, so the next thing that we now need to do, so we want to evaluate our model on random image from our data set. Okay, so that's what we're going to do. Is we're going to have like a random number, random index, then we're going to get a random image from our test data set. Then we are going to reshape the image, right? For now, let's just write that one. Then we are going to make prediction, the image that we just got, then we're going to make prediction on it. So this is our model, right? This is our model that we want to predict it on this new image that we just created. Okay, so that is done. So that is, then now we're going to do something cool. We are going to look at the image that we randomly chose from our test. We are going to show it, and we are going to see what we actually predicted it to be, so that we can see whether we are right or wrong. See, so this is the image, which is kind of 6, and we predicted 6, which is correct. So if you want to test it multiple times, you have to run it from here. So run this one again, then run this again. So it's 0. We predicted 0, which is correct. So let me run it one more time. You can do it multiple times to kind of have fun with this, you know. Let's see, it's still 0. Let me try one more time because I need another image. Oops. Well, I mean, it's still 0, but different kind of 0. But I'm going to be persistent and try to see if I can get 1. Okay, you can see 1. So you see, it predicted everything correctly. And so just like a recap, so like we were able to download the MNIST data set again, which is, you know, data set of figures. You know, we created our ANN model, you know, so we put the input shape to be this, you know, the dense layer, which is the hidden layer. I think this is the hidden layer. So with the activation function of ReLU, then softmax at the end, which is the output, right? Then we use, like, it don't need to worry too much about this. We use ADAM optimizer. There are some details about this, but I don't want to make it complex for you guys, right? Then we plot the model of our ANN, you know, to see our input, you know, and how everything relate to each other. And then we train it, then we evaluated it, then we tried it with different images, and we see that everything was correct. Okay, thank you guys for watching this video. Just like as an experiment for you, or like homework or assignment, I want you guys to change this number of epoch, right, and see how your accuracy is gonna change, right? No, you can even try to reduce it to like 2 and see that your accuracy will reduce, right? So thank you guys so much for watching my video. So in today's video, we were able to implement our own ANN model to predict figures, right? And in the next video, we are going to go more into much more complex stuff, right? So if you don't want to miss that, I will encourage you to subscribe to my channel and to, you know, share this video, like it, you know, and click on the bell notification so that you don't miss out in future videos. Thank you so much for watching my video. See you in the next video. Bye.